Hi, my name is Mackenzie Dahlbeck, and I am in Professor Curtis's Physics 2211 class. Just recently, I attended the lecture titled The Higgs Boson, and this was presented by Howard Gordon. Howard Gordon is a physicist at the Brookhaven National Observatory, which is located in Upton, New York. This national observatory actually works in part with the ATLAS experiment. And what the ATLAS experiment does is they do research on the Higgs boson. So just to give you a little background on the Higgs boson, physicist Peter Higgs proposed that all of space is permeated by a field called the Higgs field. And while this doesn't mean much to most of us, the Higgs boson actually explains why electrons have mass, and without it, atoms would not form. This is often referred to as the God particle as well. This sort of explains how our whole universe was created. This has caused a lot of debate in society as a whole. So to give you a little background on the ATLAS experiment, it consists of 3,000 scientists, which is a lot of people doing a lot of research at once. Scientists from 38 different countries, the United States being one of them. And virtually, it's just a particle accelerator to do research on the Higgs boson, which is located in France and Switzerland. So the mechanism of it is there's a detector and there's a cavern. The detector is about the size of a 5-story building, which is huge. It is comparable. It's about half the size of the Cathedral of Notre Dame in Paris. And the cavern part is a 10-story building, and this is located 90 meters below the ground. The third part of the ATLAS experiment is actually called the Large Hadron Collider, which is a giant accelerator, and this is what a majority of you are probably familiar with. This spans over the countries of France and Switzerland and is actually 16 miles long. So what happens is this collider accelerates 2 beams of protons of energies of 7 TeV, and this is about 1 million times larger than the energies of radioactive decay. So this is huge. The energy is created from strong magnetic fields from superconducting magnets just to speed up these particles. Per second, about 1 billion proton-to-proton collisions occur, which is astronomical. And you would be thinking that all of these protons are literally colliding with each other. But in fact, because protons are all over the place, there's only a few collisions, about 20, that occur per bunch crossing. So not a lot for how many proton-to-proton collisions occur. The ATLAS project was actually started in 2009, and it is expected to take data until 2030. So we are just in the initial stages of the experiment right now, so there's a lot more discoveries to come. What the detector does is the detector measures the direction, momentum, and sign changes of charged particles, as well as their energies, to help us get an idea of how the first protons came into interaction with each other, how the Big Bang happened. There's so many different questions we can answer. And what this is leading us to do is it's leading us to unify the grand theory, just to understand the universe and all of dark matter. That's really what physics is just getting a better grasp for our universe. And we want to see if our physics that we have here on Earth and that we have here in our galaxy, is going to span across the rest of the universe. And so with the help of the Higgs boson and the Large Hadron Collider, we can accomplish this. So this relates to Rutherford's experiments, which we studied in class, and just doing the scattering angle, this all goes into factor in the Higgs boson. In addition to this, it also relates fusion and fission problems, which we did over test 3. And it's a really cool way to see how these problems we do in class really get applied to the real world and to real life experiments. So as research continues on the Higgs boson and the God particle and figuring out, hopefully we will get a lot more data and kind of figure out where we came from and where we're about to go. So that is it, and I hope you learned something from this lecture and from my video talk about it, and have a great day.